We teach this in a four-step process, a four-step milling process, which just means the typical process in Woods 1 in which you would take a board and cut it to its finished thickness, width, and length. And the first step in that process for us in Woods 1 is the planer. And what the planer does is it takes a board and makes it a little thinner than it used to be. It's intended to cut face grain. And one of the first step actually in using the planer, which is the reason we cover measurement the second day of class, is that you have to be able to measure the thickness of your board, because you can't make your first setting on the planer unless you know how thick your board is. The planer is set up to cut a 1/16 of an inch off on each pass. This particular planer has a power table. There is a ruler on the front of it. We work in the standard inches, and one of the first things that students need to note about this is that it is magnified by 2. So an inch, instead of being this big, is this big. And it's also divided into increments of 1/16 of an inch. This planer has a cutter head right up in here, so it cuts from the top. So you would typically put the worst face of your board up. So the first question is, what can you send through the planer? And the first rule is the board has to be at least 10 inches long. If it's less than 10 inches long, they can get stuck between the feed rollers and not come out. We do not allow man-made products or engineered wood products to go through the planer, so things like melamine, particle board, OSB, plywood, MDF, none of those are acceptable materials to run through the planer. But what we can run is solid wood. Basically, if it was cut out of a tree, it can probably go through the planer. And also laminated wood that we glue together in here, provided that all the glue, dry glue and such, has been removed. So my first step, like I said, using the planer, is measure my board. This board's 3/4 of an inch. So I come over to the power feed table, up and down, and as I press that, the crosshair on the lens will move back and forth. And what I like to do is go just right to the measurement of the board. That tends to be easier for most students. So it's set at exactly this height, but I want to take about a 1/16 off each pass. So I'm going to go to the up button and I'm going to give it one quick tap, and that reduces the measurement by about a 1/16. Now I say about. If I have to be exact, I'll get close to it with the table, and then I can fine-tune it with the knob on the top. I can manually raise and lower the table if it has to be right on. But for most of the passes you make, where you take a 1/16 off each time, about's usually okay. Well, when I feed the board in, I want to look at it and I want to see if it has a crown on it. If it has a natural crown, I want to start with the crown up. The board's at least 10 inches long. And one of the things I want to keep in mind is that the planer can kick back. If I feed it in incorrectly or I make a mistake, it's possible to have the board come flying out of the back of the planer, which we've had happen once in 10 years. But the student had to make several mistakes to get to that point. But anyway, so I always stand to the side. You never want to get your fingers under the board, because as it feeds into the planer, there's a point in which the rollers grab it and it will slam it down tightly to the table, so you never want your fingers under it. As you go through, as it starts to grab the board, quite often students will have a problem with their boards getting stuck. We have probably more problems with the planer than any other tool in here. And the first thing I tell them to try is to increase the traction. This knob right here, if it's down around a couple clicks, that just means a little bit of traction. If I raise it up, what it does is it raises the rollers inside, it grabs the board a little firmer and sends it through. Well, a lot of people say, well, why don't you just keep it on that setting all the time? The reason is, when you do that, it makes big wheel marks in it. And the best analogy I can give is that down here around 0, it's like a racing slick. Up here, around 10 increments up, it's like a monster truck tire. And we keep it down about 3 tick marks, and that usually does pretty good. But if my board does get stuck, that's the first thing I try. Increase the traction, which raises the rollers, and usually it'll go through if I've set everything else up right. If I haven't and it still won't go through, then I just turn it off and wait. Which incidentally was how we got our one kickback we had on this machine. Board got stuck, traction didn't work, student got impatient, turned it off, but the head in here coasts for a long time. So he lowered the table, which you are not allowed to do. You have to be absolutely sure that everything stopped moving in there. Well, it wasn't. He lowered the table, he brought his board out, and when he brought it out, he tipped it. It hit the coasting head and it drew blood on his hand because it kicked back so far. Anyway, if it gets stuck, the first thing you want to do is increase the traction. So I'll set it up for my first pass. And after you've set it up for your first pass, you don't have to turn the planer off for every setup. You can send it through, bump it up 1/16, send it through again, and each time you go through, you're taking approximately a 16th off. I'm actually going to run this one first. So this board's 1.5 inches. I'll go to 1.5 inches. Bump it back up 1/16. To turn on this planer, there's 2 on buttons. One runs the cutter head and one runs the feed roller. You don't want to turn them on at the same time because they draw a lot of amperage. So you turn on first the cutter head, then the feed roller. I need to turn on my So I keep my board nice and flat, I stand to the side, I keep my fingers on top. As I feed it in, the planer will take it. I barely skim the top, it ain't quite thick enough. One quick tap up, ready to go through again. Tap up, take another 16th off. And I can just stand here all day running boards through and slowly fixing the spot up. You never want to plane a board much thinner than a 1/4 inch because they can tend to break inside under pressure. But anyway, you get the idea. You just need to take it a 16th off at a time. To turn it off, this button turns the whole unit off. This one is an emergency stop, which if something was really wrong, your shirt got caught in there or something, you could hit that and it would just cut the power. Usually we don't have to use that. So another type of board we might send through would be a laminated board. And the main point here is that if you're going to send a laminated board through, quite often one piece will be sticking up higher than another, so that when you measure your piece, you want to measure to the thickest part of the board before you send that through. So this one is about 7/8. It's just under the limit, just over the limit. Part of the board, and then just take it down a 16th at a time. This is what it'll look like when students do their Viking box lids. They'll have laminated pieces. They start with the thickest part of the board. Quite often they have to use some extra traction. But as it smooths out, they may want to back off the traction. First time that a Woods 1 student uses the planer on their own, they're going to have a pine short like this. It's going to be 3/4 of an inch. Take about a 16th off, and the final product has to be down to 5/8, which means 2 passes through the planer. You want to put the worst face up. Because it has a helical shaped head. That's normal. up, I'm at my 5/8. I look at my board again. What's the worst face now? Well, it's probably this one, so I'll send this through. That's my first step in building my blanking box, is planing my material thickness.